Alright, hello geometry. So today we're finishing up section 8.6 and we're looking at the law of cosines. And the law of cosines, the reason that we left it for a separate section is it's a bit longer than the law of sines, and depending on which version you're using, it either looks like this, or this. So I'm going to go ahead and give you a second to jot that down, or take a screenshot, or pause the video and jot it down, or whatever. And you may notice if you're looking at these that these are really just three versions of the same thing. Because we've got one of our sides squared, our other two side squared, so whichever two weren't over here, minus two of these two sides times the cosine of whatever angle is across from this side. So again, little letters are sides, big letters are angles. So lowercase are sides, uppercase are angles. Right. So really these are just three versions of the same thing, so you probably only need to jot down one. It's not going to hurt if you jot down all three. And you may notice if you're looking at that last one, c squared equals a squared plus b squared, that looks kind of like the Pythagorean theorem. And really the law of cosines is just a fancier version of the Pythagorean theorem that we can use for things that aren't right triangles. So the regular Pythagorean theorem only works with right triangles. This works with any kind of triangle. Alright. And what we can do with this is we can use this for things where we wouldn't be able to use the law of sines that we were looking at last time. Because remember, last time we said in order to use the law of sines, you need at least one pair where you have an angle and the side across from it. So we do have an angle here, but the side across from it is the thing we're looking for, and we don't have either of our other angles. Now if we had one of these two, we could use it to find the other, and we'd have an angle side pair, but we don't have either of the other two angles, so we can't find those right now. So instead of the law of sines, we're going to use the law of cosines. Cool. And I'm going to call this one A, and this one B, and this one C, and no, it doesn't matter which one you're calling which, it's just going to affect which one of your three law of cosines you're using, but they're really the same thing anyway. And watch out for across from big A is little a, the one across from big B is little b, and the one across from big C is little c. Now, if we're figuring out which one of these to plug it into, we've got angle B. So we want to use the one of these three that has an angle B in it, because angle B is one of the things that we have, so we're going to go ahead and use this one. So when we're plugging in our A, B, and C, we're plugging them into this. Now, if you'd called that angle A instead, you'd use this. If you called the angle we have angle C, you'd use this one. You're going to get the same thing. Alright, so we happen to call it angle B, so we're going to have B squared, which is the thing we're looking for, so I'm going to call that x squared, equals A squared, which is 17, plus C squared, which is 12, minus 2 times A times C times the cosine of, almost had enough room here, 70. So close to having enough room on my thing there. Okay. Nice thing is, as long as this is the thing we're looking for over here, this is just order of operations now. We can just PEMDAS this whole thing. So, exponents first. 17 squared is 289. 12 squared is 144. Minus 2 times 17 times 12 times the cosine of 70. And watch out for the cosine of 70 is just a number. So I'm going to go ahead and find that cosine of 70, which is about 0.342, and then we're going to take it times these three things. So this whole chunk of stuff here, we're multiplying. So we got exponents, we got multiplication. So times 2 times 17 times 12. So that cosine of 70 was about 0.342, so then we're taking that times this, times this, times this, which gives you about 139.5. And watch out for that still x squared. Okay, and now we've got parentheses. We don't have parentheses, exponents, multiplication, division. So now we're just down to addition and subtraction, which we're just going to do in order from left to right. So 289 plus our 144. 289 plus 144. Minus that 139.5. Gives you about 293.5. And then watch out for that's x squared. So if you're looking at that going, well, that's way too big for that side. You're right, that was way too big for that side. That's our side squared, so now we're going to get rid of that by square rooting it. So we want the square root of 293.5. Where's my square root button? There's my square root button. 293.5. Gives about 17.1. And if we're looking at that, okay, this is probably not quite drawn to scale, but that looks pretty close to, an isosceles triangle-ish here. So 17 is pretty close to 17.1. Yeah, we're in the right ballpark. And again, we can't assume that things are drawn to scale, but that's our longest side because it's going to be across from our biggest angle here. Okay, we're in the right ballpark. Now, the other thing you can do with this, oops, off the table there, is you can use it to find angles. Now, same sort of thing here. We couldn't use the law of sines for this because we need a pair of angle and side that we know both of. We know all of our sides right now, but we don't know this angle. So I'm going to call this A and B and C in some order. I'm going to call this one C this time. So C, A, and B. And again, just watch out for little a is going to be across from big A, little b is going to be across from big B, and little c is going to be across from big C. Okay. So then if we're calling this angle C, and that's the thing we want to find, we want to use the version of our law of cosines that has an angle C in it, which got a little bit smudged when I put something else on top of it, but we want to use this version on the bottom here. So this time we're using that version of the law of cosines, so a squared plus b squared minus 2ab cosine of c. Now, watch out for this is our little c. So that's going over here. So little c squared equals little a squared plus little b squared minus 2 times little a times little b times the cosine of c, and that's a big C, so this is the thing that we're actually looking for. So little c, the side goes here, big C, the angle goes here. I shouldn't use C because big C looks exactly like little c. Okay. Now, watch out for when we're going through PEMDAS, we've got 20 squared is 400, 14 squared is 196, 9 squared is 81, and we're multiplying these again, so no problems yet. So 2 times 14 times 9, 252. Now, watch out for, we can add these, but we don't want to subtract this because this has a cosine of c attached to it. So since we're multiplying by this, we're going to treat this like a variable, like if this was x. So if you had this minus 252x, you wouldn't subtract those two because we can only combine things that have the same variable. So I'm going to go ahead and add these two, but not subtract this from it. So this one gives you 277. And now if this is the thing we want, we're going to get rid of this. We're going to get rid of our 277 by subtracting a 277. And watch out for when you're doing that. This negative needs to not disappear. So this minus 252, that's a negative in front of there. So that just needs to not go anywhere. Okay. Until now, because now we're going to divide by it. So now we're going to divide by negative 252. And 123 divided by negative 252 gives you about 0.488 negative. That doesn't look like an angle, because that's the cosine of our angle. So if we want to get rid of a cosine, we're going to inverse cosine. So we're going to want that cosine with a little -1. Or if your button had an a cosine, Same thing. So you're either looking for this or you're looking for this, and we're going to watch out for that negative needs to be there, so negative 0.488. The inverse cosine of that, and again, make sure you're in degrees, because if not, it'll give you something funny. So we want the inverse cosine of negative 0.488, which gives you about 119.2. And if we're looking at that angle, that looks about right. We're in the right ballpark. That's an obtuse angle. It's going to be across from our biggest side. So we're in the right ballpark there. All right. And yeah, again, this is why this is in two sections, because the law of cosines alone gets pretty long there. And there's not really anything in there that you didn't already know how to do. We already know how to solve things once we get here. It's just a lot of stuff, and it takes up a lot of whiteboard. Okay. Alright, now, again, we're back to things that say solve the triangle, which means we're looking for all of our things. So I forgot to label this one. I'm going to call this one A and B and C, which means that the things we already have are big A, and we already have little b, and we already have little c. So we're looking for angle B, we're looking for angle C, and we're looking for little a. So those are the three things we're looking for. We already have the other ones. Okay, I should put the C somewhere else so that I'm looking at 50. Okay, there we go. Alright, so same sort of thing. If we have the one that's an angle A, we're going to go ahead and plug this into the law of cosines version that has an angle A there. So we're going to have A squared, which is the thing we're looking for, equals B squared plus C squared minus 2 times little a times little b times the cosine of angle A. So anytime you have a cosine, the thing after it is your angle. So that's your 52 there. Alright, and these are the ones where we can just go through and we can just order operations this thing, because the thing we want is over here. So exponents first, 8 squared is 64, 5 squared is 25, 2 times 8 times 5 is 80, times the cosine of 52. I don't know the cosine of 52 off the top of my head. Nobody does. If you do, good for you. And the cosine of 52 is 0.615, so we're going to take that times our 2, times our 8, times our 5. So times 80 there, which gives about 49.25. Alright. And 64 plus 25 is 89. 89 minus your 49.25 gives you about 39.7. Alright, and then again, watch out for, we need to make sure we're square rooting that, because that wouldn't be a reasonable side length for 5 and 8, but once we take the square root of 39.75, we've got about 6.3, which does look like a reasonable answer. Because that's our middle-ish side, so that's going to be across from our middle-ish angle. Okay, we're in the right ballpark. Cool. Now, once we've got that, we're looking for one of our angles. I'm just going to erase some of this so that I don't have to write the whole thing out on the whiteboard. There's that part. Maybe pause the video if you're not done jotting that part down somewhere. And now we're going to find angle B or angle C. So if I want angle B, I want to use the version of the law of cosines that has an angle B in it. So we're going to start with our B squared, so 8 squared equals A squared plus C squared minus 2 times A times C times the cosine of B. And B is the thing we're looking for. So again, if you're looking for an angle, that should be over here. So angles are over here, sides are over here. And now it's some order of operations. So 8 squared is 64. 6.3 squared is, well, we got that from 39.75 in the first place. Technically, if you take 6.3 squared, you get... Yeah, so if you just took 60.3 squared there, then you're going to get 39.69. If you remember that where we got that 6.3 squared in the 6.3 in the first place is we square rooted the 39.75, you can also use that. Technically, you'll get something slightly different, close enough. Okay, and then we get 25 minus 2 times 6.3 times 5. 2 times 6.3 times 5 gives you about 63. I should have known that one off the top of my head because 2 times 5 is 10. Cosine of B. Okay, and then again, we're adding these two, but not combining it with this one. So this one's going to give you a 64.75 minus 63. Cosine of B. It's around 64. And then we're going to subtract that 64.75 there, which gives you a negative 0.75 here, equals your negative 63 cosine of B. And yeah, watch out for not to lose either of those two negatives. So we got negative 0.75 divided by negative 63. Which gives about 0.012. And then we're going to inverse cosine of that. Should have left myself a little bit more room. So the inverse cosine of 0.012 is about 89.3 degrees. So that was B. Should have left myself a little bit more room to write that up here. Okay, angle B is 89.3. So this one was pretty close to a right triangle, the way that we had that drawn there, which kind of makes sense. Okay, that looks pretty close to a right angle there. Alright, and then we're looking for angle C. Now, instead of going through and doing this all again with angle C, I mean, you can, or the other thing you can do is we have two angles, so we can just take 180 minus our 52 minus our 89.3. So 180 minus your 52 minus your 89.3 gives you about 38.7. So once you got through your angles, you can just subtract to find your third. Now, technically, you can go through and do all of this, but why? Don't do that. Okay, and that's it for that one. We've got the three things that we were looking for. Alright, like I said, this is kind of long. So if we don't have any angles or sides labeled on our triangle, we can just go in and throw A, B, and C on there somewhere. So I'm going to call this A, I'm going to call this B, I'm going to call this C. And again, little a is across from big A, little b is across from big B, little c is across from big C. And this time we're looking for all of our angles. So we're looking for angle A, we're looking for angle B, and we're looking for angle C. And again, once we got two of them, we can just take 180 minus the others to find your third. Okay. So let's go ahead and find angle A first. So if we're starting off with angle A, we've got 13 squared, because that's little a, equals little b, plus little c, minus 2 times little b times little c, times the cosine of, what did I say, a. Almost had enough room there. Okay. And then it's just order of operations. 13 squared is 169. 23 squared is 529. 17 squared is something I should know by now. 289. That's what it is. 289. Minus 2 times 23 times 17. Which gives about 782. Cosine of A. And again, watch out for we're adding these, but we're not subtracting this one from it. So we got our 529 plus our 289. 529 plus 289 gives you 818. Minus our 782 cosine of A, because this one has a cosine attached to it and this one doesn't. So we got 169 there. And now we're subtracting 818. which gives you negative 649. And don't lose this negative, or if you're going to, lose them both. Technically, that would work too. But don't do that. Okay, and now we're going to divide by negative 782. So negative 649 divided by negative 782 gives you 0.8299 equals your cosine of A. And then we're going to inverse cosine your 0.8299. Inverse cosine 0.8299 gives you about 33.9. Okay, so angle A is about 33.9. And again, things aren't drawn to scale, but yeah, that looks like it's in the right ballpark. So this is our shortest side. It's going to be across from our shortest angle. We're in the right ballpark. Okay. And now we're going to do the same thing with either angle B or angle C. So I'm going to use angle B. So if we're looking at angle B, we've got 23 squared equals angle little a is 13 plus little b squared minus 2 times little a times little b, nope, that was little c, times the cosine of, we were looking for angle B. And if you happen to forget which angle you're looking for, it's going to be the one across from this side. So that was 23, so that's going to give us this angle. Okay, 23 squared is something I probably just found before and didn't remember, 529. 13 squared is 169. 17 squared is, I think that was 289 or something. Yeah, 289. Okay, 289. Minus 2 times 13 times 17. 2 times 13 times 17 gives you 442. And watch out for we're adding these two, but not this one. So 169 plus 289 gives you 458. Minus your 442, cosine of B. So subtracting a 458. Minus 48 gives you 71. Equals your negative 442, cosine of B. And watch out for don't lose that negative, because now we're dividing by it. So divided by negative 442. Gives you about negative 0.1606, around that up to 1, equals your cosine of B. And now we're going to inverse cosine of that. So the inverse cosine of negative 0.161 gives you about -0.161 is about 99.2. For angle B there. Okay, and again, not drawn to scale because this looks a little bit bigger than that, but that's our biggest angle. It's going to be across from our longest side. And then once we've got those two, we can just take 180 minus our 99.2 minus our 33.9, which gives about 46.9 for your other angle. So once you got two of them, instead of going back and doing all of this, just take 180 minus the two that you've already got. Okay, again, these are kind of long, which is why we split this into two sections. So go ahead and check out the homework in the description below, and I'll see you in the next section.